Yes, good day, everyone. Welcome to Datalytics from Theory to Practice. We'll be talking about the lab session for ridge regression, how to implement ridge regression using R. Now, in the earlier video, I mentioned that penalty is added to ordinary least square in order to remove overfitting problem. Yes, so this time around, and it was mentioned that the lambda, as lambda increases, the coefficient shrink to 0. A larger lambda brings about shrinkage, reduction in the coefficient. So we'll be looking at the lab session this time around using R. Welcome to the channel once again. Thank you. Towards 0. Now let's look at an example. Now suppose we have y 2, 3 up to 13, x1, 6, 0 up to 4, then x2, I mix it up, I put it at x3 anyway. So fit ordinary least square to the data, fit regression to the data. What are we supposed to do? Now using a software, we are using R. So y is equal to 2, 3, we code it. This is code for R. Then we combine the data to form a data frame, and that's a command. Then we fit the OLS regression model, and then we use LM as a function. Then y regression x1 plus x3, because I use x3 there. Then data equals to data. Then we display the model. So summary. Now this is what the output looks like. The output comes out this way. We have our the coefficient of x1, x3. You can see what we have. We have our R square. I just said R square and the rest of them. Now let's look at the ridge regression. R code for ridge regression. For ridge regression, you have to install a package called GLMNet. So if you have not installed it in R, so you call the GLMNet, you fix in the code, we combine into matrix, we define our response variable, then our alpha is equal to 0, where if you are doing ridge regression, our alpha equals to 0. Then we use our GLMNet function and get the result. Then we also plot, and that's what we have. So in a case where our lambda is equal to 0.1, very, very small lambda, we have, and then when our lambda is high, which is s, we specify s to be 100. So we see what our coefficient will look like in the next slide. Now, when our x equals to 0.1, that represents lambda. So we can see that it's close to that OLS. 0.1 is very small. But when our lambda is equal to 100, we can see that the coefficient moves closer to 0 as compared to when our s is equal to 0.1. S here, according to the programming, is actually the lambda representation. And this is what it looks like. The coefficient here, x2 or x3 as the case may be, we can see when lambda increases, we can see that it shrinks towards 0. You can see the actual coefficient we have is minus 0.33 something. Then the other one is what, 0 point something, like we have here. This is just a representation of the output. So now we are drawing the curtain for ridge regression. Thank you for watching, and I want you to remember to subscribe to this channel, ask your questions, comment. Thank you for watching.